Hi, I'm Gary Keplinger, Dr. K to most of my students. Today we're going to look at a particular bonus problem, number 34, from this book, Math is Cool. If you're interested in the book, go to our website at keprad.com, and you can order it directly from our printer in paperback form, or you can get a downloadable PDF format. And teachers, you do have permission to copy anything in that book. So on this particular problem, staggered starts in track. It's a circumference and diameter problem. But first, let's look at track. If a person is running a 400-meter dash, that person's going to stay in their lane the entire run. If the runners started side by side, the person in lane 2 would be running further than lane 1. The person in lane 3 would run even further yet. So to rectify this, we have what's called staggered starts, that everybody gets to start a little bit ahead depending on the lane. That way everybody runs the exact same 400 meters. Now, a couple of things that we need to point out on this. On our problem here, the lanes are going to be 1 meter wide, and we're going to measure our circumference of the problem using the inside of each lane. So as you look at a track, that's what the track would look like. And again, if everybody started at the finish line down here at the bottom right-hand line here, then you would be running too far. So we've got the staggered starts that will move up onto that curve to the right. Now, if you want to try this problem, now would be a good time to try it, because the next thing we're going to do is we're going to look at the solution. Again, those are some of the points we made. The curved part of the track is the key to solving the problem, because everybody runs a straightaway. So as we look at that curved part, and we're going to look just at lanes 1 and 2, because that'll give us our staggered start that we need for any of the lanes, that when you put the curved parts together, we have circles. The red circle represents lane 1, the blue represents lane 2, the black line would be the finish line, or also where lane 1 starts, and lane 2 would start there, except for the staggered start. But we're going to compute the problem based on lane 2, person on the blue lane starting right there, to see how much further they would be running if they did not have the staggered start. So we have two circumferences. We have the one in red, which the circumference of lane 1 is pi times diameter of lane 1. Circumference of lane 2 is pi times diameter of lane 2. You'll also notice a couple of things about meters there that make this problem a little bit easier. Because when you start comparing the diameters, the diameter of lane 2 is 2 meters longer than the diameter of lane 1. The meter at the top, the meter at the bottom. And we're going to use that fact to point out that diameter of lane 2 is equal to diameter of lane 1 plus 2. So in our formula for circumference of lane 2, we're going to do a substitution. Instead of d2, we put d1 plus 2. And then you see on that last line, we use our distributive property. So we have circumference of lane 2 equals pi times diameter of 1 plus 2 pi. But pi times diameter of 1 is actually circumference of 1. So instead of pi times diameter of 1 that you see on the next to the last line, we're going to substitute back circumference of 1. So now we have circumference of 2 is the circumference of 1 plus 2 pi. And that 2 pi is what our stagger needs to be, because otherwise the runner in lane 2 would be running an extra 6.28 meters. So to compensate for that, we move the staggered start for lane 2 up 6.28 meters, and lane 3 would go up another 6.28 and so forth. And so that is our solution to this problem. Again, if you want to check out our website, go to keprad.com. And I've found that this is a great supplement for when I'm teaching various courses, but I've heard other people say it's a great supplement for them, also for their kids at home, or if homeschool teachers could use it as well. So check it out. Check out our other publications and offering. Keprad Publishing is a division of Keprad Enterprises.